Wild West. So there's this line that's been often attributed to the first person to make it to the South Pole, which is that adventure is just poor planning. And I think he was saying it to sort of talk down that like an expedition to the South Pole isn't an adventure, it's something you plan out. But this has always rung true to me as the less I plan, the more fun I'm gonna have. So let me tell you about this adventure I've been on. I bid on a robot. So I'm going to draw you to a few details on this eBay listing. First is the bidding war. I was the only bidder. And also when I took this screenshot, I was very embarrassed that I had spent $700 on this thing. So I redacted that. But the second thing I'm going to draw your attention to is shipping. So a few of you may hack on old IBM mainframes and come across this before, but for me, I didn't know what to expect. And at this moment, I now own 1,700 pounds of robot in Connecticut. Turns out I needed a semi-truck, and I also don't own a semi-truck. But I didn't need a whole semi-truck. I just needed LTL, less than truck. So I went online, I got some quotes for what less than truckload means. And it turns out you also need a forklift operator at both ends, because semis don't have any kind of way to, I mean, they will gladly make sure that there's a forklift at each end, and all for like higher and higher prices along the way. So I got a quote to ship my $700 robot from Connecticut to Colorado for $1,932.13 for 1,700 pounds of robot of class 85 material, which just meant like machinery on pallets. I was living here at the time with 4 roommates, none of whom owned a forklift. Our college house did not have a loading dock, and but our neighbor across the street owned like a heating and air conditioning plumbing company, and I asked a huge favor, and so he took delivery of these 2 pallets, and there's another pallet of all the cabling. And that was, I won the auction on November 11th, and November 30th was when these robots got delivered. And it turns out that Yellow Freight can issue a corrected invoice. What that means is that when you get a quote for 1,700 pounds of robot, and you end up shipping 2,155 pounds of robot, they ask for an additional $700. So then I spent a few months trying to find someone with a warehouse space, or this is in 2011, so there definitely wasn't like maker spaces in Fort Collins, Colorado. So I was just like trying to find anything. I was talking to people who owned auto body shops. I'm like, just give me a corner, like somewhere where I can hide. I won't do much. I just need a little bit of power, 3-phase, 480. And no luck, no one answered my Craigslist ad. So then on Valentine's Day, my welcome had officially been worn out at the plumbing company for having these giant robots sitting in the corner. So I rented a box truck with a lift gate on it and rented a pallet jack so I could roll this thing into my garage. And I started taking it apart. I was trying to figure out how it worked, what it was, like what this crazy piece of machinery did. And then I also had to try to figure out a way to get it off the pallet, using only the tools that I could afford at this point. And a bit of luck. So you can see there's actually a third one here that is, this is right before I slid off the pallet and like slid a bolt through and hoped it wouldn't fall down. And this was the celebratory beer and the pallet that had landed. And you can actually see there's concrete dust around the corners from where like loosening these bolts were slowly drilling into the concrete. Quick side note, that base is 1-inch thick plate steel. So the robot itself weighs 700 pounds. The base was easily another couple hundred. So now that the robots were grounded, trying to figure out what to feed these things. What do robots eat? So these robots eat 3-phase power. City of Fort Collins wouldn't run 3-phase power to a garage. And even if they could, I wouldn't have been able to afford the installation cost. And so just like normal power lines, the three-phase power in my neighborhood was like just out of reach. But it turns out you can fake it. But why would you want to? So if you look at the sine wave here, what you're seeing is standard AC line voltage from the wall, right? So if you're trying to operate a piece of big, heavy machinery, those zero cross points kill you, because at the point where the sine wave crosses the zero mark, you have no power available. So what does that mean is that if you wanted to run this kind of robot on single-phase power, you would need a tremendous amount of capacitive storage to get you through that dip. So if you wanted any power in these moments, and the robots could move at any time and draws a ton of power as it does, you need something to get you through that lull. Three-phase power gets around this, because if you look at the full-wave rectified three-phase waveform, you can see that there's always power available to you. So this means that the controller needs less capacitive storage, and capacitors are, crazy expensive, and they go bad. So then I sold my motorcycle, my last non-frivolous asset, or my last frivolous asset, and drained the last pennies from my savings to buy a rotary phase converter. So a rotary phase converter, you send in single phase power basically into a three-phase motor. This is a terrible thing to do. It takes, this three-phase motor is about 7.5 horsepower. It takes 10 amps to run it. And so you are just burning energy turning this thing with like a gnarly waveform. But the idea is that you get this idler generator. So if you're trying to draw power during those lulls, you can actually pull off the rotor inertia a bit like a generator. And this lets you get through those momentary dips. So then I built a little contactor box. This is a very dark photo. And now I had three-phase 220 in my garage, which was great because inside the robot, there was this giant transformer that had a ton of taps, like a lot of taps, like 30 taps across the top. So what are the odds that there's not a tap that I can run 220 into this thing? And even though the nameplate on the robot says it runs on 475, I thought I'd be able to swing it. So I did what any reasonable person would do, and I called the 24-hour ABB hotline. I told the poor on-call engineer on the other end that I needed to move this robot across the factory, and someone had disconnected it, and I didn't know where the taps were, and I needed to like get this thing back online. And he's like, okay, hold on, let me go dig some of the old manuals out of storage, because this robot's from 1987. So they're not used to getting these calls. And he called me back with some bad news. All of these taps are designed to take in anywhere from 400 volts AC to 600 volts AC three-phase. And a step-up transformer for a three-phase is really expensive, like $500 to $1,000 used in like an unsure state. But luckily, there are salvage wreckers in the world who are heroes. There was an amazing toothless guy 3 hours away who had found this, which I give him credit for, because had you found this and survived, that means that it was probably on a building that wasn't powered. I paid $75 for this. Him and his buddy helped me load it into the back of my Honda Civic, and it took about a couple days for my friends to come home. They were out of town at the time, and I couldn't get it out of the trunk on my own. So this is a 9 kVA transformer that takes in, the high voltage side is 480, low voltage side is 208. But one of the wonderful things about transformers is you run them forward, you run them backward. So I put in 220, I got about 470 out. So then with all the, everything in place, we threw the breaker. Oh, wait.
Oops, sorry. Light on, phase converter. Up to speed, sounds good. Transformer activated. Dun, 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 dun. Oh, we have lights. Yeah. Oh, shit.
Oh, sorry, I was swearing on the radio. Okay, yeah, sorry about the shakiness. I was very excited. I was also like terrified. And then this was the first message from the robot. So it took almost a year, and it said 510 system error right after that, which meant that there was an issue with a 300-volt supply. So great, we had all the power up, we turned it on. Like, turns out when people sell things in unknown condition, it can be pretty bad. So the power board needed some love. You can see that on the right, there's a component that's just totally missing. There were some legs fried off of other things. Some capacitors. It's sort of hard to see in here, but this is just blackened on the left-hand side. This resistor had a hole physically blown through it, which is pretty cool. So then I just removed a bunch of the monster components, just testing things as you do. Some of the big capacitors, these are the size of a pint glass. And you can see around the negative terminal there's some corrosion from where the electrolyte may have leaked out. So put a little 1K resistor on it. I should say at this point in time, my only piece of test equipment was Harbor Freight multimeter. So to test a 350 volt, 2 microfarad cap, it needed just a little RC circuit. So, I'm sorry, not 2 microfarad, 3,300 microfarad. So yeah, I just used a multimeter and a stopwatch. Turns out all the caps were fine, as far as I can measure. So then rebuilt the board, put it all back together, and then it was time to fire it up again.
I just heard a sound from... That was a huge pop. I saw a spark.
So when we fired it up for the first time, got a little bit of an arc flash inside the cabinet. And a new message from the robot, 506 servo error 2. A couple of the transistors had physically blown themselves apart. This is a 500 volt, 7 amp peak, or 7 amp continuous, 40 amp peak transistor that had blown itself in half. And you can actually see it. You can pass around some pieces of cool robot brain. Yeah. What's cool is on the back of that board, too, you can see there's this channel, sort of like on Mars, so you can see where the rivers used to be. You can see where one of the copper traces were. And it actually deposited this fine copper spray paint on the board behind it. I also promised to talk about transistor matching. One of the cool things is that, 1987, these high-power transistors are extremely expensive. So they did a lot of binning to actually match transistors. And so you can see that these guys are actually in parallel. And as you look at that board, you can see there's everything is like a matched set. So whenever you're doing transistor matching, that little half ohm difference between, or half micro ohm between 2 transistors can make a huge difference as one is heating up faster than the other, which is actually why you can see one of these is just fine and the other one had a really bad day. I also built a transistor matching spreadsheet as part of all this, so if anyone wants to check that out, you can send me an email, I'll send it over. So I realized at this point that Fred wasn't going to move anytime soon. Actually, if you look at that board carefully on the top, there's a big Sharpie X on it, and I didn't put that on there. So this robot sold in unknown condition. May have been a bit bad. So Fred is also filled with ASICs. So I'm going to pass this around. This is Fred's brain. This is the main processor board for the robot. So what? Oh yeah, 1987. Yeah. That was the controller. I'm not sure if anything on that had been upgraded since then. So there's a few people in the Hackaday community who decap and figure out how ASICs work, the amazing Tamagotchi work. But I'm not that person. And I was very worried that I would go and spend a couple $100 fixing the transistors on this board and then blow an ASIC and never be able to get it moving again. So with Fred just kind of standing guard over the bicycles in the garage, I kind of did what any sane person would do in this situation. And I rented an engine hoist, turns out the right tool for the job here. And I also rented a truck, and I acquired another robot. and moved into a warehouse in the industrial part of town. I called it the warehome, which was great because my neighbors had forklifts now, and they were more than happy to let me borrow them to move these weird robots around. I also made like a little bit of grass. It's kind of hard to see in this photo, but you know, there was no windows in here, so I thought like a little patch of grass would be nice. And so that was the robots in their new environment. And the other thing was, during this time, renting a warehouse was like pretty expensive, even though it was out in the industrial part of town. So I sublet the space next to the robots to some friends of ours who were starting a food truck that sold sausages. So during this period of my life, I didn't go camping because everything in my life smelled like sausage. So this was me bolting the robots into the concrete. I also got the landlord to pull a 100-amp service of 220 into the corner. And then, yeah, this was measuring it out and landing them. And then this was them actually planted into the ground. So, like, economies of scale, I think, come to mind, but I'm not sure what that means. So LEFTY is this newer robot here. LEFTY is from a Kodak packaging facility where they used to handle X-ray film, and so it's like brand new. It was in a clean room almost for most of its life. Its controller cabinet smelled like a new radio. And then Fred was like pot-marked from welding and just totally beat up. He spent his life at a Pratt & Whitney jet engine manufacturing facility welding. So at this point, I was like, okay, I'm probably not going to get these controllers working again. So I started to try to figure out how they actually work. And I was realizing, too, that trying to figure out how to hack into a serial port on a set of controllers from 1987 that may have been missing that like feature that they sold for like comms in the background wasn't going to let me just set arbitrary positions and speeds. And then, you know, if I did get it up and running and I blew an ASIC or if the comms port went dead, it would all be moot. So what are these robots? All they are is 6 servos held together with an aluminum casting and some gears. So another representation of it just as nodes and joints. But these are pretty monster servos. They can really rip 300 degrees per second on all of the wrist axes and 115 on the body. And this is especially impressive when you consider that the arm itself weighs 700 pounds. And on top of that, these gearboxes that are in here, they recommend an oil change only once every 5 years of continuous operation. So they're built extremely well. They're like a Swiss watch. And all these castings are enormous, too. So this robot has a 1.5 meter reach. And this is actually a slice because it rotates around the center axis. So there's a sphere that it can move in. And one of the coolest things about this is it can reach down below its base. Like if we take a step back and like just talk about what a servo is for a second. Inside a servo is just a little hobby servo. You have a motor, gear train, a feedback mechanism, and a control system. So in this case, it's a DC motor, plastic gear train. There's just a potentiometer on there. And then the PCB is the controller, which just takes a error signal from your pulse width modulation you're sending in to generate an error signal that controls the motor. But if you want to spin more than 360 degrees, you're likely moving to something like an encoder. So a rotary encoder is an optical device, and it will generate a pulse train based on the direction of rotation. And so as the shaft rotates, your code wheel will move, generating this quadrature signal on the output. You can add a bit of information to that, which is a home point. And so once a rotation will get a note as sort of a source of truth. You can go a step further. So this is a code wheel for an 8-bit encoder. So anywhere along here, you can have absolute position knowledge within one rotation to a resolution of 2 to the 8, or 256 positions. You can go even further. These are 16-bit off-the-shelf encoder wheels, which it's a very high shelf. They're extremely expensive. But they're great for like stable, clean applications, anything you need like precision motion again and again. But the problem is these are glass usually at the higher rates, or they're made out of like very thin metal, so they can be extremely fragile. So for a higher vibration environment, I present the humble resolver, which is a weird piece of technology that I had never heard of, at least. So in a high noise environment, like on a rocket, for the thrust vector controllers, or for a robotic arm, these are like one of the coolest little physics packages that are out there. The way it works is you have a center coil, which you excite with a sine wave, and then you have effectively a sine and cosine that you pick up off the outside of that. So as you excite that center exciter and rotate it within that stator, you can see these signals changing on the output. And then with measuring the magnitude of those signals, just a little bit of simple trigonometry to figure out where your rotor position is. So these analog position sensors have the fascinating trait that the resolution is only tied to your ability to generate and measure sine waves, which means that their resolution is theoretically infinite. It's just... and what's also ridiculously cool, since the center exciter is actually generating a magnetic field, and this thing is spinning, at high speeds, what you can actually generate is a generator. And so you get this DC offset in your signal because you have this, you have a rotating magnetic field within two coils. So you've built a little tiny generator. So if you can kind of hear this, there's like, this is the B7. There's a 4 kilohertz sine wave that's used to excite these, which give these robots their like characteristic hum in the background. So when you have an entire robot that's filled with these resolvers that are excited all at the same frequency from the same driver, the entire structure ends up singing, which is kind of cool. So at this point, I had bought a top-of-the-line O1 oscilloscope. And so this plastic scope is showing the signal from the resolver when the shaft is between the two coils exactly. And then as you rotate it, you can actually see the signal for one go in and out of phase with the other as it's rotating through that space. So then I added a little controller to calculate it, and I had sort of position sensor from one of the axes. And so this is the resolver package from axis 4 on the robot. An interesting side note, Fred was the low resolution version of the robot, so it just had one resolver per axis. And so you had to bring it back to a home position, but that still gave it sub-millimeter precision anywhere within that 1.5 meter sphere from its base. What's amazing is LEFTY, the other robot, had 2 resolvers, one with a 90-tooth gear and one with a 91-tooth gear. And so the 2 resolvers are out of phase, so you power it up and you have instantaneous position knowledge. Because the 2, anywhere within that space the robot can travel, you'll never recreate the same phase offset between those 2. It's just like, it's a really amazing tech that was put in 1987 and is still absolutely bleeding edge, state of the art. So then I was super excited to figure out what was happening, and I opened up more parts of the robot, and it turned out the next thing I opened up was a gearbox. And it just like had never even occurred to me that this giant robot could be filled with oil. And so I open this thing, it just starts drooling gear oil all over the ground. And at this point, I picked up a set of old manuals for the robot, and I found the exact gear oil specification I needed, and I went to every auto parts store, every distributor I could, until I finally ended up at like a Shell distribution station, and they had the oil I needed, or one of the like 8 options. But it turns out they only sold it in 5 or 55-gallon drums. So I bought a 5-gallon bucket of robot oil. This should be enough for 90 years of oil changes on the robot, if they're operating 24/7, which they're currently not. And that's also on an aggressive preventative maintenance schedule. Since they're not moving all the time right now, if anyone needs some robot oil, I got some. Happy to share. Once I got the gearbox refilled, I decided to take another crack at getting the robots moving again using these old controllers. So I just started pulling ROM out of one of the boards. So that board is actually like half made up of ROM from one robot and the other, and there were cards sliding back and forth between the two and all sorts of chaos. And then, like in the middle of the night, I don't know why, it suddenly started working. And so this was like the first motion of this robot that had been sort of like kicked around from storage sites and moved. But you can hear this 700 pounds of machine, and it moves just with that little 4 kilohertz hum. So I was over the moon, but I didn't quite know what to do with this newfound ability. So I was trying to just bake things up. So I had it like picking up toolboxes, which wasn't super exciting, but it was kind of fun. Oh, that's the sausage truck. Yeah. Yeah, it was pretty nice. Common link. Oh, and actually, oh no, it's good. But then I had it like pour some champagne because I was like, well, that seems like the right thing for a robot to do. It's pretty great. Then I had it open beer bottles. So at this point, I had effectively built like a tiny bartender. But then I just started making it go like faster and faster. So then once again, like the thing to keep in mind with this is 700 pounds. So if you started this up and there was like a trash can or something around, it would just knock it clear across the warehouse. Most sort of industrial settings have like light curtains and cages, and I just don't think that's a proper way to store such a wild creature. But then I put a bike light on it, and I turned the lights off, and I started doing some long duration photography with it, which I just thought was the coolest. And then I added a whistle thing that I found on Hackaday a while ago. And so then I would whistle, and the robot would come, and I would whistle again, and it would go away. So the dangerous thing about this, though, is like I am like very happy just in general. Like my personality is one to like wander around whistling. And so I would leave the robot on, and I would start working on something else. I'd just start whistling, and then this thing would come whipping across the shop, which was probably not a super safe thing. So then I was like, okay, well, this robot is actually from before ABB. There was a company called ASA, which is the A in ABB. Oh, sorry. Which is the, from ASA, which was the A in ABB. And ASA has a very tragic logo. And if you ever want to look that up, it's not good. So I decided, though, that this robot wasn't really ASA anymore. It was now Fred. So then I ground off the old raised lettering, got a laser cut stencil, threw some Bondo on it, sanded it down, threw a coat of primer on it, and then all I needed was a paint job. And I knew just the robot. So this was Fred painting his own forehead here. And then after a couple rounds of this, it was perfect. Except this is total smoke and mirrors. He was terrible at painting, so this is all by hand. Then almost as soon as they had gotten moving, I was dragged out to San Francisco, and I put the robots up in storage over about a weekend. And I was living out here, but I was really missing my robots quite a bit. So I ended up on eBay again. And I bought another 2 axes, which brought my full count to 14. And this was $70. You got 2 axes for $70. It was like $50 to ship it to San Francisco. And then this is when the project really starts going off the rails, just even further. I decided that instead of doing like a microcontroller-based thing and like building off of these other libraries that exist, I wanted to write the entire thing from scratch in VHDL on an FPGA, including all the PWM blocks and everything. So this was some VHDL model sim outputs that were then running the first like open loop test here of the wrist. Eventually, like moving on to like little 40-volt tests. So you can see this like sort of going back and forth here, but this is totally open loop. And then it started getting a little bit more aggressive. And I decided that I would start moving on to the closed loop testing. And this was a resolver to digital converter board that ADI sells. But actually, what's more interesting is in the back here, there's this red circuit board. I wrote a Dear Santa letter to Analog Devices. This dev kit was about like $400, which I didn't have the cash for. And so I said something along the lines of, Dear Santa, just straight to Analog's main contact page. All I want for Christmas is the ADP 104080 Val-Z. And I went on to explain about the robots and what I was working on. And I ended the letter with, well, some say that the magic is gone from corporate America. I still believe. And I was a little bit drunk when I sent this message. And I heard nothing back for a couple weeks, which is totally understandable. And then someone from Analog accidentally forwarded me the entire chain, and it went all the way up to some VP of marketing who was just like, don't bother me with this, just like send the kid the dev kit. And so then I got this response from them saying like, yeah, send us a shipping address, we'll get it to you right away. But they ended with, if a real customer needs it, we're going to take it back. I was like, all right, that sounds fair. So then I went and found a warehouse at 6th and Mission that were another windowless place, which I don't recommend living, and got a box truck and road trip these guys out to San Francisco. And so, yeah, another windowless, unsanctioned living situation brought on by having these giant robots, my mechanical friends. And so it always gives me a little bit of eye roll when people are like, I can't find a place to live in San Francisco because like they won't take pets. And I'm like, yeah, that's a bummer. So then started getting the closed loop test set up, just like all sorts of crazy circuit boards wired to other things. You can see no shielding on anything, just lots of noise. But then it started working. So I got one axis of closed loop control up and running. But then the landlord of the crappy warehome decided that it would be much more profitable to be Class A office, and they kicked us straight out. So then I got a shipping container over in Hunters Point, which is where they're at now. But at this point, the entire project sort of pivoted into a software problem, which brings me to the next part of this. What I love about this project is it continually reminds me that I know absolutely nothing. So this is the only useful part of a sine wave, which I hadn't realized before. And so if you're using anything more than this much in your lookup table, you're just wasting memory, which seems like something I should be optimizing for. So if you look at sort of an overlay of a sine wave, it's all just that same information mirrored. And then what you can do once you have that quarter wave lookup table is generate three-phase waveforms. So this is a three-phase waveform generated from that quarter wave lookup table on the FPGA. What's really interesting about three-phase waveforms is they can actually be expressed as just two sine waves. And this is called the Clark transform. And then from that, you can also do another transform called the Park transform. And what you actually get is the entire sine wave, or the entire three-phase waveform expressed as two DC components. And what's really interesting about that is if you're trying to control anything, if anyone's ever run a PID loop, it's a lot easier to send in a DC signal than it is to send in a three-phase waveform. So this is called field-oriented control uses this theory a lot. And there's some amazing videos by Dave Wilson out of TI that I highly recommend if you start going down this rabbit hole. And then you can run it all backwards. And so from that, get into a three-phase waveform again. And so that kind of brings us to where we are now. And so it's been about 8 years of hacking away on this project. Lots of learning, lots of mistakes. I have a Fred's notebook over there if you want to flip through it, which has a sticker on the front of it that says, always check the sensitivity list in VHDL. I don't know if anyone else has been burned by that, but I've lost a lot of time because of a stupid bug. It's on the cover of my book. But I just go through and I try to document what I'm working on and hack away and just constantly learn from all of these mistakes and learn a lot about really interesting theories that I wouldn't have come across otherwise. So most of my work was in high-speed electronics, and so I would never have gotten into high-speed motor control or high-power electronics. And so basically, I can't recommend highly enough picking up a pair of these robots. At least one. It's logistically difficult, but the barrier to entry is a lot lower than you might expect. As these systems become obsolete, as factories upgrade, as factories close, there's more and more of them on the market, and people are going to start hacking away on them. There are crazy scrappers out there who are selling like just pieces of it. I got this for $70. Other people are selling it for $1,900. They're selling that like busted piece of circuitry we're passing around for almost $500. But then there's other places on there, on eBay, where you can get the entire robot, a controller that's filled with all of these parts that we just saw for $1,000 or best offer, because they want to get rid of this thing. And they're being sold for basically scrap value. This is a gantry crane with 2 inverted ABB 2400 arms on it. All the controllers to run the whole thing. This was in a factory in St. Louis, Missouri. The opening bid was $25, and I was the only person who said I was interested in bidding on it. But then I talked to the riggers, and I tried to figure out whether this would even fit in a 40-foot shipping container broken down, and so I ended up not buying this. But at that same auction, there was another dozen lots that had KUKA and ABB arms that were starting at $25 with almost no one interested in bidding on them. Mostly these things are going to scrappers because there's so much aluminum and copper in them. And there's also some that are just abandoned. So this is a factory in the UK where they have just a stack of these robots rusting away. So, like, sort of in conclusion, working on these things have been an absolute blast and a constant learning experience. I sort of look at them as my 69 Charger. It's that project like I'll constantly hack away on in the garage, and it has no timeline and a seemingly endless budget. Thanks for the attention, and I implore you to start your own home for broken robots and start building a weirder future with me. So, thanks. Any questions?
Yeah, we got questions?
Yeah.
Did you have some purpose that you were going to do with the robots? Was there something that you were, maybe in the beginning?
Yeah, so the initial goal was to teach them to make a mojito. Because it like slicing a lime and like, the cool thing is when they park, you can park them in any position and they draw no power. And so you could actually have them like watering a plant and like holding, becoming a lamp and then setting the light down, watering it, taking it back, and then just parking with no power. But the real long-term goal is I want to mount 2 of them upside down on a roller coaster track inside a greenhouse and have them just tend to the greenhouse. So that's the...